Today's topic is reviewing the Pythagorean theorem. So you can use April 22nd as the date on your notes. And this is the note packet that you'll need for today's lesson. So let's start with some basic facts. First of all, if you have a right triangle, there can only be one right angle present. If you had more than that, we would not actually have a triangle. The figure itself wouldn't close. So there's the right triangle. Notice we use the block in the corner to mark the right angle. Because the right angle is the biggest side, it's going to be across from the hypotenuse. And we know that the hypotenuse is always the largest side. The other two sides we refer to as legs. So in the diagram, they're calling them leg 1 and leg 2. When we look at the Pythagorean theorem, we use A and B. So if you recall, this is the Pythagorean theorem, a squared plus b squared equals c squared. C is always the longest side, so that's the side we'll use for our hypotenuse. And then A and B are our legs. So let's look at our first example. These are very straightforward. They're giving you the value of A and C. They're telling you that B is missing. So we're going to sub directly into the Pythagorean theorem. So we have 12 squared plus b squared equals 16 squared. We're going to go ahead and square those numbers. So I have 144 and 256. And we do want to isolate b squared. So I'm going to subtract 144 from both sides. And I'm going to get b squared equals 112. At this point, we're going to square root both sides so that we can just get b. We don't want b squared. Now, we've been working with simplifying square root radicals, so I do not want a decimal. I want a simplified square root. So you need to find two numbers that would multiply to 112, but one has to be a perfect square. And remember, the bigger the square, the better, so that the process will end sooner. So I went through my calculator. I started dividing by 4, and that will work, but you'll have to repeat the process. But I found 16 will work, and it's a bigger square. And 16 will simplify to 4, and then we have radical 7. So my missing side B has length of 4, radical 7. Let's do the same thing with example 2. Notice that B and C are provided, and they're both in square root radical form. That's all right. We're going to sub in what we have. We're still going to square the square roots. In our last lesson, or on Monday, we said that when you square and square root, those are inverse functions, and they basically wipe each other away. So in place of B, we'll have 8, and in place of C, we'll have 16. And now I'm going to subtract 8 from each side, so I can isolate A squared. And again, we'll square root. And don't be fooled, 8 is not simplified. It needs to be factored further. So my squares are 4, and the other factor is 2. And this will simplify to 2 radical 2. We also have what's called the Pythagorean theorem converse. Sometimes they will provide 3 side lengths and ask you if these 3 sides can form a right triangle. So we're still going to use the Pythagorean theorem. What we'll do is we'll sub in all 3 sides. If you can get the left side of the equation to equal the right side of the equation, then you can say, yes, these 3 sides would make a right triangle. But if you sub in and the left side and the right side are not equal, then that triangle cannot be classified as a right triangle. So let's try our first example. In number 3, they're giving me 14, 48, and 50. Now 50 is the largest side, and that needs to go in for C. So we do want to be aware of that when you're subbing in. All right, so we're going to come up with all of our squares. So if the left side does add up to 2,500, and yes, it does, then we can conclude here and say that these three sides can form the sides of a right triangle. In example number 4, here's my three sides. They did not put them in the same order, so we want to select our largest side, which is 35, and make sure that goes in for C. Okay, so we're going to go ahead and come up with our squares. And when I add the left side, I see that I have 1525, and that is not equal to 1225. So I'm going to say that these three sides cannot form a right triangle. One of the things that mathematicians use are called Pythagorean triples. This is a set of three positive integers, which when subbed into a squared plus b squared equals c squared will always balance. And typically, we don't get a third side to be a whole number. We've seen square root radicals or decimals. So some of the most common triples are 3, 4, 5. So if they show you a right triangle and you know that the legs are 3 and 4, hopefully you'll remember that the hypotenuse is automatically 5. And you could just write triple instead of showing me the work. Another very popular triple is 5, 12, 13. 13 is your hypotenuse. And just another is 8, 15, 17. There are 41 natural occurring triples. I'm not going to list them all, but if you have the ability to recognize these, you could save yourself a little bit of work. This is the homework, number 111 in your packet. You're going to do all the problems, 5 through 20. Make sure you read the directions. If you'll do this on the white space or on the back of this page, if you prefer to do it on separate paper, that's fine as well. Make sure you scan in the work with the assignment when you send it over as a PDF. If you have any questions going through this assignment, please make sure you contact me. Otherwise, have a great day.